All right, Mr. KJ. So we're going to be looking at the ideal gas law examples that your teacher provided you with. We're going to start out with number 6. Um, so first, what we're going to want to do is start out with writing out the equation, right? So that way we have an idea of what ideal gas law is. And we've already covered this, so I'm not going to spend too much time on it. I'll give you a brief refresher. This particular version of the ideal gas law um, specifically talks about initial and final, right? So this talks about an initial pressure um, and its change in pressure. Its initial volume, its change in volume, initial amount of a gas, number of a gas versus its change, what this gas is at its resting point, at its final position, at the moment they check it. So if we want to think of it in terms of an object, we can have helium in a balloon that starts at 11. I poke a hole in that balloon, which obviously is going to mean that some of that helium gas is going to seep out. And so we go from 11 to, let's say, 5. So all of your changes are going to happen on the right, hence the sub 2. So anytime we're talking about a change, and that's denoted, if you look at the problem, when we read number 6, we'll better understand it. But it kind of always happened from left to right. All of your initial, your beginning states like pressure, volume, amount of gas, and temperature are going to be in the very beginning of the problem. And towards the end, they'll always tell you what the changes are. So it always goes in order of sequence, right? So let's go ahead and read number 6 since we have an idea of what this version of the ideal gas is. Number 6 reads, a balloon is filled with 29.5 grams of oxygen gas. The volume of the balloons at room temperature, which is 30 degrees in this problem, the volume at room temperature is 5.75 liters. The balloon leaks O2 gas, and by the time this is discovered, it has a volume of 3.25 liters. So there's our change in volume. How much O2 gas is left in the balloon? How much is leaked out? So automatically we know that we are looking for this guy here, the change in the O2 gas. We know that we start out with 29.5 grams of O2 gas. Something happens to the balloon, a leak happens, and all of a sudden we want to find out how much gas is left when the leak is found out in the system. So we know that this is what we're looking for. We're looking for the change in O2 gas. So everything else will be provided in that. So that should be the first thing that you do whenever you're dealing with a problem like this, is to, once you read it, identify what it is that you're looking for, circle it, because this will help you stay on track. You know, if you're looking for this guy, everything else will be provided in the problem.